Welcome to wasrats.com. Hello students, in this video we are going to start a topic from chemistry. Let's see what topic we are going to start today. The topic is carbon and its compounds, and it is a part 3 video of this chapter. You know that we have done part 1 and part 2, and I think you are aware of this chapter now. Like, as you know that what are hydrocarbons, you know what are saturated, unsaturated hydrocarbons, you are aware of alkane, alkene, alkynes, and also you know about the functional groups. And in part 2 we did the detailed study of the functional groups, that was alcohol, carboxylic acid, aldehyde, ketone and ester. So now we are going to start with part 3. Let's see that what topics are left that we are going to cover in this part 3. So the topic which we will be doing in this video are some important reactions of hydrocarbons, that is alkanes, saturated hydrocarbon, and unsaturated hydrocarbon, that are alkenes and alkynes. So let's study about the detailed reactions which are involved, or you can say that the properties of alkanes, alkenes and alkynes. So let's study about alkane first. So we know that the alkanes are those in which there is carbon-carbon single bond. That is, throughout the length of the chain, we get to see that all the carbon atoms are singly bonded. They are singly bonded. There is no double or triple bond present. So the primary functional group which is involved in case of alkane, that is the single bond between carbon atoms, and the suffix which is used is called as ane, and you may know that it acts as a primary suffix. Primary suffix is that which indicates the type of bonding, For example, if I write methanol, right? So meth is word root, an is the primary suffix which is indicating that the bonding in the between the carbon atom is a single bond, and all is the secondary suffix which indicates the functional group. So alkanes, alkenes, alkynes, they all act as primary suffix. So the alkane suffix which is used is ane. So it is specified by writing ane at the end of the name of the compound. And if we talk about members, we know that how to make those members. The first member we know is methane, right? We did that how we actually form it. The second member is ethane. Third member is propane. Fourth member is butane. Fifth member is pentane, and so on. You know how to make these members. Now let's study about the chemical properties of alkanes. So the first chemical property which we are taking into consideration is pyrolysis of alkane. Now the first thing is that what do we mean by this term pyrolysis? See, lysis, wherever it is written, it specifies breakdown. So pyrolysis of alkane means that we are breaking alkane by supplying it with heat. So that means we can define a pyrolysis of alkane is breakdown of bigger alkane into smaller alkanes. And how we do it? We do it by heating. So it is breakdown of bigger alkane into smaller alkane by heating. Let's take an example. Let's say if we have hexane. We know that hexane is C6H14. So if we heat it, then it will break into the smaller alkanes. Let's say, like if we are heating the hexane, we are getting here the smaller alkanes. Let's say, suppose we have C4H10 and the another one is C2H4. So you notice that one component which is formed is the alkane, that is the smaller alkane, and the second component which will be formed will be alkene. So it gives rise to the smaller alkane, and sometimes the alkene is formed. But in few cases, like if I take an example of the first member of alkane, that is methane. So if I heat it, or you can say I'm like pyrolyzing methane, what do I get? I'll get carbon and hydrogen. We are going to get carbon and hydrogen. So that means in this case, we are not getting alkane or alkene, we are just getting its constituents. We know that alkane is formed of carbon and hydrogen. So that is the reason. It is the lowest alkane. That is why we got carbon and hydrogen. So likewise, we can pyrolyze any alkane, and on pyrolysis, it may be a chance that we are getting two smaller alkanes, right? There may be a chance where we are getting one alkane and one alkene, and there may be a chance like if we are dealing with the lowest member, then we get its constituents, that is carbon and hydrogen. So basically it is actually involving the breakdown of alkane into its smaller members, like into a smaller alkanes, or into a smaller alkane and alkene, or into its constituents. The second thing is oxidation of alkanes. Here the oxidation refers to controlled oxidation. And you know that whenever we talk about controlled oxidation, that means we are not burning it. It doesn't involve combustion. It is controlled oxidation. That means we are reacting with oxygen in presence of certain catalysts, and it will not burn alkane. It will somehow produce some other product. This is what is called as controlled oxidation. So whenever we carry out oxidation of alkane, we get to see that it transforms into different compounds depending upon the catalyst which we are using. So we have seen that alkane on oxidation can give the alcohol also. The alkane on oxidation can give the aldehyde also, and alkane on oxidation can give the carboxylic acid also. So which compound will be formed by oxidation, that depends upon the catalyst which we are using. Let's say if I take an example, let's take an example of ethane. Suppose I have ethane and I am oxidizing it, right? And let's say I am oxidizing in presence of copper. So if I am oxidizing in presence of copper, we'll get alcohol. So it is ethane. It is neither step down nor step up reaction. We are going to get the same word root compound. So it is ethane. So on the right hand side, what we'll get ethanol. We'll get ethanol. And similarly, if ethane is oxidized in presence of molybdenum oxide, then we get aldehyde. So this is ethane. So what we'll get ethanol. We'll get ethanol. And we know that ethanol is something with this formula, that is CH3CH. And if we are oxidizing in presence of silver oxide, then what do we get? We get the ethanoic acid. And what is the formula for it? It is CH3COOH. So what compound will be formed after the oxidation of alkane? That all depends upon the catalyst. So you need to remember that if we are using copper, we get alkane converted into alcohol on oxidation. If you are using molybdenum oxide, it transforms into aldehyde. And if we are using silver oxide, it transforms into carboxylic acid. And carbon atom remains same. Like if you are starting with the certain word root of alkane, the same word root compound is formed on the right hand side. So just there is a difference of group, or you can say it transforms into a different compound, but the number of carbon atom remains same. Third reaction which we are doing for alkane is substitution reaction. So first we'll study that what do we mean by substitution reaction. Substitution, as the name suggests, here an atom is going to substitute the another atom. One atom is going to substitute the another atom. For example, like in your school, if your physics teacher is absent, then what happens? There is a substitute. Some other teacher comes to your class and take your class. She might not be a physics teacher, but she's substituting. She's trying to substitute your physics teacher. Right, so that is substitution, a kind of replacement, you can say. So substitution reaction is a reaction in which a group of atom is substituted, or we can say is replaced by another atom. a group of atom is substituted or replaced by another atom. This is what is substitution. Substitution reaction is shown commonly by alkanes. They are shown by alkanes. And you know that there is one substitution reaction of alkane which is very famous, and it occurs in presence of light. In presence of light. And that is called as chlorination of methane. That is chlorination of methane. So chlorination of methane, that is the substitution in methane which is caused by chlorine. That means some atom of methane is replaced by chlorine. That is why it is called as chlorination of methane. So let's see that how it starts. So in this we have methane chlorination. That means chlorine is reacted with methane, and as a result chlorine substitute one hydrogen of methane. So what do we get? We get CH3, one hydrogen is replaced by Cl, so it becomes CH3Cl, and along with that we get H and Cl, that is HCl. The compound which is formed is chloromethane. The compound which is called as chloromethane, or it can also be called as methyl chloride. The common name is going to be methyl chloride. That is, first we are going to write the alkyl group and followed by the chlorine, so it becomes methyl chloride. But you know that this reaction occurs in presence of light, and it is a sort of chain reaction. It keeps on occurring till the time all the hydrogens are replaced by chlorine. So as you can see that in chloromethane still we have 3 hydrogens that could be replaced by chlorine. So the reaction continues in presence of light. This chloromethane reacts with more chlorine, again in presence of light. One more H is now replaced by chlorine. So what do we get? We get CH2, Cl2, and along with that we get HCl. So how we are going to name it? It is dichloromethane, because 2 chlorines are there, so it is dichloromethane. And if we talk about its common name, it is methyl dichloride. It is methyl dichloride because 2 chlorines are present. Now there are 2 more hydrogens, so the reaction again takes up. CH2Cl2 combines with more chlorine in presence of light, and one more H gets replaced. Now it becomes CHCl3 plus HCl. And what is the name for it? It is trichloromethane. It is trichloromethane. And do you know that what is the common name for CHCl3? It's an important compound and it is used as a sedative. It is chloroform, not a sedative, it is an anesthetic. Like if you want to give an anesthesia, the chloroform is used for that. So chloroform is CHCl3, which is a common name for trichloromethane. Then again it possesses one H which can be replaced. So this is replaced by reacting it with more chlorine, and as a result we get CCl4 and HCl. And CCl4 is tetrachloromethane. It is tetrachloromethane. And it is a quite, you can say, a useful reagent which is used in lab. And the reaction stops here because at this point the CCl4 doesn't possess any hydrogen which could be replaced further by chlorine. So this is what is substitution reaction, and here the substitution of hydrogen is occurring by chlorine. Therefore, it has a specific name for this reaction, that is chlorination of methane. So this kind of substitution reaction can be used for different alkanes. Like in this case, we use chlorine. So in another reaction, we may use bromine also. But chlorination of methane occurs in presence of light. But bromination doesn't occur in presence of light. So this is an example of photochemical reaction, and the mechanism is substitution, and the specific name for it is chlorination of methane. Next we are going to start about alkenes. Right, so let us see what properties alkene. So in case of alkenes, carbon-carbon, they are bonded by double bond. That is, if we look at the entire length of the carbon chain, we get to see that at least at one position there is a double bond found. And apart from this, the other carbon atoms, they might have a single bond, or they may have a single, or at some position there may be one more double bond. So, but you can say in a member of alkene, it is mandatory that at least at one position the double bond is present, and it is unsaturated hydrocarbon. It is unsaturated hydrocarbon because here the carbon-carbon are bonded by double bond. And the suffix which we use is "ene". Again, "ene" specifies the primary suffix, which indicates the type of bonding which is present with the organic compound. And similarly, we can make members also. Like the first member, we start with eth, right? So it is ethene. So what is the formula for it? Ethene is C2H4. The another member is propene, and the formula is C3H6. The next member is butene. The formula is C4H8. The another member is pentene, and the formula is C5H10, and so on. So likewise, we can make different members for alkenes. So I think you got it. And if we talk about the general formula, it is CnH2n. It is CnH2n. So this is the basic introduction about alkenes. Now let's learn that what important reactions, or you can say the chemical properties, are alkenes, or what chemical properties does alkene possess. So they commonly show an addition reaction. Now first thing, that what is addition reaction? Look, addition reaction is a reaction, as the name suggests, that it has the ability to add some atom or some group of atom. It may add some atom or group of atom. And the reason that they show addition reaction is because of the presence of extra bond in them. As I told you, that minimum, like at one position, the presence of double bond is mandatory. So in this case, because it has one extra bond, it can be replaced, and in order to stabilize the valency, we can add a group of atom or a atom to it. So addition reactions are shown only by the compounds which possess extra bond, or we can say addition reaction is a property which is shown only by alkenes or alkynes and some other functional group also which possess double bond. But here we are talking about alkenes and alkynes, so let's focus on alkenes first. So in the addition reaction, let's say if I have a compound ethene and I can add anything. So let's add bromine, hydrogen bromide to it, let's say. And the another reaction, let's add bromine water to it. Let's add bromine water to it. So what happens? The addition occur across the double bond. Only the carbons which are having an extra bond. So what happens? This H gets attached to one of the carbon and bromine gets attached to the another carbon. So as a result, we get CH3, the bond becomes single, and CH2Br. So this is what is formed. So it is what it is called as. It is called as bromoethane, and as a result, it gets converted into the alkyl halide, or you can say the alkane with a halogen. Similarly, if you add bromine water, again one Br will get attached to one carbon and one Br will get attached to one carbon in order to stabilize their valency. So we get CH2 bond becomes single, Br and Br. And how we are going to name that? So it is 1,2-dibromoethane. It is 1,2-dibromoethane. This reaction is a reaction between ethene and bromine water, and it has a practical importance as this reaction is used to test the presence of alkenes, or you can say it is the identification test for the alkenes, because when this reaction occurs, then bromine water gets decolorized. Bromine water gets decolorized. So whenever if you have an unidentified compound and you react it with bromine water, and if the decolorization of bromine water occurs, that means this compound is formed due to an addition reaction, and it is a test which is shown by unsaturated hydrocarbons, that is shown by alkenes as well as alkynes. So this is an identification test for alkenes and alkynes, or you can say a test for unsaturation. Another reaction is hydrogenation of oils. It is one of the application of the addition reaction. It is one of the application of the addition reaction. So what does it means? Hydrogenation of oil means that we have an unsaturated fat. We have an unsaturated fat, and to it we are adding hydrogen, and this addition occurs in presence of catalyst nickel, and as a result hydrogen gets added up and it forms the saturated fat. So hydrogenation of oil means conversion of unsaturated fat by adding hydrogen in presence of nickel into a saturated fat. This is what is hydrogenation of oils. So let us take an example. Let's say we have unsaturated fat. Let's say we have ethene. We are adding hydrogen in presence of nickel. The hydrogen gets added up because of the addition reaction, or you can say because of the extra bond present. So it will transform into ethane and it is a saturated fat. So this is what is hydrogenation of oil, that is converting the unsaturated fat oils into a saturated fat oils. This is what is hydrogenation. Hydro means hydrogen, genation means addition of hydrogen. So you can define it as hydrogenation of oil refers to converting the unsaturated fat into saturated fat by adding hydrogen in presence of nickel. In presence of nickel. So this is what is hydrogenation of oils. The next property we have is combustion. Next property we have is combustion. So combustion means burning the substance. Combustion means burning any substance. And we know that for burning any substance, three conditions are necessary. One, there should be a combustible substance, that is a substance that can catch fire. There should be a supporter of combustion, that we know is the oxygen gas, and there must be a proper ignition temperature, that is the temperature at which substance catches fire. So whenever we are burning any hydrocarbon, let's say it is alkane, it's alkene, or it's alkyne. So whenever you are burning it in presence of oxygen, the compounds which are formed is always carbon dioxide, water vapor, heat and light. So this is what we get. And this type of combustion is called as uncontrolled oxidation. It refers to uncontrolled oxidation, which means burning substance. It is not, you can say, a property in which we are going to get aldehyde, carboxylic acid or something else. So whenever you're burning any substance, you're carrying out combustion. It occurs when the combustible substance, supporter of combustion, and proper ignition temperature is present, and as a result we get carbon dioxide, water vapor, and energy is liberated in the form of heat and light. So these were the basic reactions of alkane, alkenes and alkynes. So alkanes possess different kind of reaction, they are showing different properties, and as far as alkenes and alkynes are concerned, because both are unsaturated, so they show common properties. So with this we finish our video. Thank you for watching this part, and for more learning experience please visit to www.wasarax.com.